All right. So what we have right here, I'm going to turn the light on so we can see it. Solving this rational, do we have a common denominator? Yeah, so if I'm going to wipe it out, what am I going to multiply everything by? 3x. Very good. We balance the scale by doing it to all sides and all pieces. And so therefore, 3x times 1, there's nothing in the denominator for the 1 to cancel, so it's going to become 3x. 3x times this, what happens to the 3x's in the bottom? Cancel out. I'm left with plus x squared minus 5x minus 24 equals, those are going to cancel out, x minus 6. Okay, that's the number one step. That should be the only new thing or the only new concept that we're working with. From this point, when I say solve this, every one of us should go, oh, okay, I can solve this because that's just a quadratic. And when we solve a quadratics, what are we looking for again? Zeros, and therefore that's the x-intercepts. So if I'm looking for the 0, then I need this side it set equal to 0. So let's combine our like terms and get it in the proper form to solve. And so I can combine those two. I still see this issue happening. On the same side, you don't do the opposite on the same side. You're combining like terms, you do the sign that's on there. So this is 3x minus 5x, which makes negative 2x. Minus 24 equal to x minus 6. And now I have the ability to go ahead and to get this into the equals 0 form. So I subtract the x from both sides, and I add the 6 to both sides. So I subtract the x here, add the 6 there. This is going to cancel out, and I'm going to be left with x squared minus 3x minus 24. Nope. X squared minus 3x minus 18 equals 0. Sorry about that. Now, we're going to factor it. Okay? I'm going to factor by grouping. I'm going to factor by grouping every time because I don't want to do so many different things that you, Joe, what am I supposed to do? Okay, I'm going to be consistent. You will go to other teachers, you will ask other people for help, and there's a lot more other factoring methods out there. I use factor by grouping because it works for polynomials higher than x squared. So that's why I use it. Okay? And so, since we have our coefficient equal to 1 right here, what we got to do is ask the question, what multiplies to give me negative 18 and adds to give me negative 3? So we got to do. What numbers are those?
5 and negative, no, 6.
3 and 6. 3 and 6 is going to work out. We got to put our sign somewhere. Where we got to have it?
Negative 6.
On the negative on the 6, right? Negative on the 6. So now we bring our original down, and we're going to split it and expand it. X squared plus 3x minus 6x minus 18 equal to 0. So those of you that thought you were going to escape quadratics just because we finished that chapter, sorry to break your hearts. It's I do it before. Yeah. So GCF in the first one is x. It's going to give me x plus 3. GCF in the next one, that's going to also give me x plus 3, is going to have to factor out a negative 6, and it's going to leave me an x plus 3. Now I got each piece I can set equal to 0. It's factors. So my factors are x minus 6 and x plus 3. By this point, can you tell me what the zeros would be?
Yes.
What are they?
6
6
and negative 3.
and negative 3. Can anybody else tell me that, or just one person? Just one person. All right, and so what we'll do is we'll go x minus 6 equals 0, and then x plus 3 equal to 0. Okay? Got to take the zeros of each individual factored piece, and so therefore we're going to add the 6. X is going to equal 6, and we're going to subtract the 3, and x is going to equal negative 3. Now going back to the solutions put it in, it looked to you probably like a coordinate. Okay? But the solutions were written like this. Those are brackets. Anybody know what those brackets represent? There you go. It represents a set notation. It's saying that the solution is in a set of -3 and 6 only. Okay, -6 and 3, or -3 and 6 only. It's not a coordinate. It's not a coordinate, -3 and 6. Okay? If you want to talk about it being a coordinate, then this would be -3, 0 and 6, 0, because those are the x-intercepts, or the zeros, as we would say.